Hello and welcome to this second video on time, speed and distance. In this video, I'll cover the concept of relative speed. We'll also look at two very important scenarios that frequent in the exams, one on trains and second scenario on boats and stream. So let's get started. First, I would like you to focus on this concept of relative speed, something which is very common. So what is relative speed? When two bodies are moving, the speed of one body with respect to another body is the concept of relative speed. So for example, if I say there's a body A which is moving, and let's say there's a body B which is moving in the same direction, and let's say the speed also is same, let's say speed is equal, what may appear to, let's say, body B, that body A is stationary, or that means the speed of A is 0. And why do we feel that is? That is the concept of relative speed. On the same concept, a lot of questions you will see with on trains. It could be involving cars, etc., etc. So now, what happens in relative speed? There are two things that happen. One is with respect to direction. So in direction, there are two things. One, your same direction, and the other is when the bodies are in opposite direction. Now, I discussed this concept of same direction. So what happens in the same direction? In the same direction, if let's say there's an object which is moving at a speed of s, let's say the object is A, and another object which is moving in the same direction, and let's say the speed is sb of this object B. So your relative speed becomes SA minus SB. This becomes your relative speed. That means speed of A with respect to B or speed of B with respect to A becomes your SA minus SB. That means in the same direction, what will happen is the speed will subtract. Whereas the case of, let's say we discuss the case of opposite direction. In opposite direction, if you see, so for example, if let's say you must have traveled in train, and what happens is, let's say your train is going at a certain speed, let's say 60 km/h, and let's say there's another train that crosses your train, and let's say the speed of another train is 40 km/h, but it feels very fast. And why it feels very fast? It feels more than 40 km/h because of this concept of relative speed, because you are seeing with respect to another train. So the relative speed in opposite direction actually adds up. So in this case, your relative speed becomes 60 plus 40. So it feels faster. And this is the concept of relative speed. On the same concept, there are some scenarios on trains especially. So let's discuss some of those scenarios. Okay. So now in exams, let's say there is this case 1, which I assume, which is the case on, let's say, train and man or person or pole, whatever that is. So what will happen in this case is that they are saying, let's say there's a train is going in a certain direction, and let's say there's a pole or there's a woman standing and is stationary. So they're saying if the train is, let's say, 100 meters long and this person is standing and this is stationary, that means speed is 0, and this train is running at, let's say, 36 km/h, how long will the train take to pass this person? That means ultimately what will happen is for the train to pass that person from here to here, right? So this is very, very easy. Now the relative speed concept is sort of not really applicable, because when you're saying the speed of this object is 0, so what you have to do is you have to assume that the train will cover a distance of how much? The train will cover a distance equal to the length of the train. This is very, very simple concept. Why? Because the breadth of this person or the pole is insignificant compared to the length of the train. So that means the train covers distance equal to the length of its train. speed is already given, that means 36, opposite same direction, anyways the other person is stationary, so it doesn't make a difference. So that means speed is 36 km per hour, which you can make into meters per second. So let's say 10 meters per second, and you can calculate the time. So this is one scenario that will come. This is in this case also scenario 1. Scenario 2 could be where the person is also walking. So if it walks in the opposite direction, of course speed, your relative speed will become speed of train if in the opposite direction plus speed of man, right? However, if the person is walking in the same direction, it will become speed of train minus speed of that man, right? And your distance would be the same, because the breadth of the man is insignificant with respect to the length of the train, though this will be the distance would be the length that of the train that it will cover, and you can calculate the time in this case also. This was case 1. Now let me take case 2, wherein they say there's a train and let's say there's a platform. So the question would be, there's a train which is in a certain direction, and can you tell me how long will the train take to, let's say, pass this platform? So train is, let's say, 200 meters, whereas the platform is, let's say, 300 meters. Now in this case something changes. So platform, again relative speed, I mean, would be for platform is 0, it's stationary obviously. So this is 200 meters, so your speed of the train would be, let's say, is given, let's say, as 45 km per hour. So your speed is already given. The distance that you will cover in this case, the train will have to cover to cross this platform, would be the length of the train plus the length of the platform. So this is something that is important here. In the previous case it was insignificant, the breadth of the man with respect to the train length, whereas here it would be this 200 plus 300, and you can obviously calculate the time. So this is case 2. Case 3 is when they say there are, let's say, 2 trains. One is, let's say, the case of same direction. So in same direction what happens is, so let's say they are saying there's a train A and there's a train B. Now if let's say this is 200 meters long, the other train is, let's say, 150 meters long, and they are saying that they take, let's say, 10 seconds to cross each other, right? Can you and the speed of, let's say, one is given as, let's say, this train is given as 18 meters per second. They may ask you, can you tell me what is the speed of this train? So again, same concept. Now distance would always be, whether in the same direction or opposite direction, distance that they will cover to cross each other would be length of train 1 plus length of train 2, which is in this case, let's say, 200 plus 150. Your speed in the same direction would be obviously minus, right? Speed of opposite direction would be adding, right? Speed of train 1, speed of train 2, and if it was in the opposite direction, you will subtract this and you can take out the time. So these are the 3 scenarios that come on trains. Let's solve a couple of questions to further this understanding. So we are given this first question. It says a train is running at 54 km per hour. If it crosses a pole in 20 seconds, the length of the train is. Now very simple. The train speed is given, so ST is given to us, right? So ST is given as 54 km per hour. You should orally know this. 54 is nothing but 15 meters per second, or 54 into 5 by 18, you get 15 meters per second. You are already given a time, which is it crosses a pole in 20 seconds. Okay, so what you have to calculate the distance, right? Now imagine in this case, very simple case, this is the pole and this is, let's say, your train, right? So what the train has to do, train has to just travel its own length, right, in order to cross this pole, isn't it? So that means distance would be nothing but the length of the train, and that is what is asked. So now distance is what? Speed into time, which is 15 meters per second into 20 seconds. So this is your 300 meters. So this is extremely easy. You can calculate the answer in 5 seconds. Okay, let's see, there's another question and they're saying a train 500 meters long moving at a speed of 36 km per hour crosses a train 400 meters long coming from opposite direction in 30 seconds. Okay, time is given and the length of both the trains is given. Speed of one train is given. Speed of the second train is what we have to find out. Okay, let's imagine this is train 1 and let's say this train is 500 meters long, and let's say there's another train, right, which is let's say 400 meters long, and they are saying this train is running at 36 km per hour. Okay, and crosses a train 400 meters long coming in opposite, and they take let's say 30 seconds, right, to cross each other. Now we know when they're moving in opposite direction, your relative speed would be how much? Your relative speed in opposite direction adds up. That means 36 plus whatever, let's say this is x km per hour, and this is what we have to calculate, right? Now time is also given as how much? Time is given as 30 seconds. Your distance that they cover in order to cross each other would be length of train 1 plus length of train 2. In this case, this is given, so 500 plus 400, this is 900. Your distance is given, time is given, distance is given. Can't we calculate the speed? This would be distance upon time. This is 30 meters per second, right? Because this is in second and this is in meters. So 30 meters per second, very, very easy, right? This is given 30 meters per second. This is what? This is the relative speed, remember, right? So this is 30 meters per second, this is 36 km per hour. This should be oral, this is actually 10. So that means your 30 is equal to 10 meters per second plus x meters per second, right? That means x is nothing but 20 meters per second. This is something we can calculate. So your option is third option. Extremely easy. So what we did in this question, we understood the concept of relative speed, and we know the distance they will cover equal to length of both the trains, right? And we just converted the kilometer per hour into meters per second to get to our answer. Now let's move to this concept of boats and stream, which is the third concept and second concept in this video, the major one. Now this is very similar. This is analogous to, let's say, examples on escalators sometimes, right? That a man is walking on an escalator. So let's imagine that there is a river, and let's say this is the stream. Okay, this is flowing in this direction. So now we obviously know basic physics, right? So what is downstream and what is upstream? Now the water always flows downstream, right, due to gravity, right? So gravity always make the water flow downstream, right? And this is one concept, and second is, let's say, upstream, right? So this is basic terminology. So what they may say is, they may say, okay, imagine if you are in a boat, right, and let's say you are rowing this boat, and let's say once you're going downstream. So what happens is, when the water is not still, that means the water is flowing in the downwards direction and you're going downstream, and let's say the speed of your boat is, let's say, u, and the speed of water is, let's say, v. So your relative speed becomes how much? It will obviously become u plus v, meaning you are going at certain speed, the water is also pushing you down in the same speed. So this is be the relative speed. Now what is the case of upstream? Again, this is common sense, right? How when we walk down the hill, we walk faster, right? Because gravity is pulling you down, you're going down. Similarly, when you go up the hill or when you go rowing against the stream of the water also, same thing will happen. So relative speed would be how much? It will become u minus v. Why? Because your speed of the boat minus the water which is pushing you back, right? So this will be the relative speed in the upstream case. So this is the only concept on boats and stream. Let's attempt maybe one question to further this understanding. So in this question it says, a boat speed of which is 10 kilometers per hour in still water. Okay, so here they're saying still water. Okay, the speed of boat is 10 kilometers per hour. Okay, so speed of boat is already given as 10, goes 30 kilometers downstream and comes back in 8 hours. Okay, so total time is given, time is already given. 8 kilometers. And how much is the distance it has to cover? 30 kilometers downstream, 30 kilometers upstream, because it says it also comes back. So in this case, if I say total time is 8 hours equals to how much? Distance upon speed. How much is the distance? 30 downstream upon, with what speed? 10 plus the speed of the stream, because they are saying downstream, right? This is T1, right? And 30 upon 10 minus V, because they are saying now it goes upstream also. So in upstream, of course, you'll subtract the speed of stream. So 8 equals to this. Now, can we not find out the value of V? Come on, you can simply solve it, or you can also, use options. So let's say 10 km per hour. This can never be the answer. Imagine, can this ever be the answer? Because see, this will be 10 minus 10. I mean, this is 0 and this is infinite. So obviously this option is not good. 5 km per hour. So let's say 30 upon 10 plus 5. So how much will this be? 30 upon 10 plus 5 is 15. 30 upon 15 is 2 plus 30 upon 10 minus V. V is 5. So 30 upon 5, 6. So that means this is the answer. So very, very easy. So I think we come to the end of this video. In this video, we learned the simple concept of relative speed. We also saw scenarios on trains, different scenarios, and we also learned the concept of boats and stream. So thanks for watching this video, and I look forward to seeing you in the next video on average speed and races. Thank you.